Harmony of the Seas can carry about 5,500 passengers, together with 2,300 crew members. They produce about 312,000 gallons of wastewater daily, and it all goes into the sewage system. There are two categories for the wastewater on cruise ships: gray and black. Gray water comes from laundry, showers, baths, and kitchens. Black water comes from bathrooms. The highest volume of wastewater comes from gray water. It gets mixed with some of the black water and is sent to the bioreactor. First, all the solids are filtered out, and after that it goes to another tank where bacteria are added. They do their job by eating small waste particles and cleaning the water. After they're done, the liquid in the tank is already pure enough. But it also gets cleaned with ultraviolet light. Chlorine and other chemicals aren't used since they're bad for the sea's ecosystem. At the final stage, the water is analyzed for its bacteria content, and in case any harmful microorganisms are still found, it's sent for extra cleaning. They say that the water that gets thrown overboard after all these procedures is still cleaner than the ocean water. That's why some harbors allow its disposal into the sea within the 12-mile sanitary zone. The solid waste that was filtered at the first stage.
So, now you have a tank rapidly filling up with black water, or raw sewage as it's commonly known. What on earth can you actually do with it? On shore it all goes to sewage treatment plants, and actually on a ship the exact same thing happens, albeit on a slightly smaller scale. Down in the engine room you'll actually find a full-blown sewage treatment facility. Let's break it down and have a look at how it works. As sewage enters the system, it first passes through this filter. All this does is skim off anything particularly large. From there it passes into the next chamber, the aeration chamber. This chamber is actually filled with aerobic bacteria. Aerobic just means the bacteria needs oxygen to be able to survive. If we were to just dump all the sewage in here, the bacteria would soon use up their oxygen, so we actually use air blowers to give them a constant supply. With oxygen and the sewage as a food source, the bacteria are set to work. All this is just an accelerated form of decomposition. Remember, these bacteria are all alive. This is why ships are so careful with the chemicals they use in their toilets. The last thing they want is to go and kill all these helpful bacteria by accident. So, now our little friends have digested all the sewage, it's on to the next stage, and this is the settlement chamber. It's a bit like a cocktail that you've left out for too long, you know, where it separates out into layers. In our case, the dense, heavy material sinks to the bottom, and the water floats to the top. It's easy enough to deal with the dense stuff. You can actually just send it back to the beginning and you kind of keep cycling it through the bacteria until they've eaten through all they can. Saying that, at some point it will become so dense that it gets caught in the filters, and then it can be removed and either sent for incineration or landed ashore. The fluid stuff at the top, which by this stage is practically just water, then gets cycled into the final treatment chamber, and this final treatment is just sterilisation. It could be chlorination like we use in a swimming pool, or it could be another high-tech method like UV treatment. Basically, we're just making sure that the last of the harmful bacteria is gone. Finally, we're left with a result that's water that's perfectly safe. It's actually safer than some drinking water. Of course, on ships we don't send it for drinking, we actually just send it to another storage tank, where it can wait until the ship is in a geographic.
In particular, the treatment and reuse of wastewater are therefore extremely important. Hydrogen peroxide and peracetic acid can be used in many water treatment applications. Thanks to their eco-friendly properties, hydrogen peroxide and peracetic acid are increasingly replacing environmentally harmful chlorine compounds. Hydrogen peroxide, either alone or in combination with an activating agent such as an iron salt, UV light, or ozone, can directly oxidize organic substances in what is known as an advanced oxidation process, AOP. AOP technology is an effective method of wastewater treatment, particularly for degradation of problematic organic molecules and other harmful substances in industrial wastewater streams from chemical and pharmaceutical plants. Hydrogen peroxide decomposes only into water and oxygen. This additional oxygen source supports aerobic bacteria in the degradation of organic molecules, therefore enabling more efficient biodegradation of harmful substances. Hydrogen peroxide and peracetic acid also help in wastewater treatment in car washes and cooling towers. Both products are gaining